All right, here we are, last page of notes for this week. So today we are going to talk about how to find the surface area of the remaining solids. We did prisms, we did cylinders. Normally I would do this in two separate notes. Normally I would do today surface area of pyramids and cones, and then tomorrow surface area of spheres. But I kind of just felt like it made more sense instead of, like, I didn't want to give you 4 videos of notes in 1 week. But I also felt like it just made sense to do all surface area in 1 week, right? It makes sense to get it all done. So I just kind of put them together. So if you do have questions about pyramids, cones, and spheres, please let me know. They like I said, pyramids and cones go together. Spheres, off on their own. But I didn't want to make a whole nother video with a whole nother page of notes for you to copy when we could just put it together a little bit more compact. So please, if you do get stuck, ask me and I will help you out. So page 31. Here we're going to jump right into it. We already know what surface area is, so here is the 3 formulas you need. The surface area of a pyramid is found by using... Now remember, the difference between prisms and cylinders versus pyramids and cones is that prisms and cylinders have 2 congruent bases on either end, while pyramids and cones have 1 base, with triangles on the sides making up the rest of it. So for a pyramid, you have 1 big B. Remember, big B means area of the base, plus P times this little cursive L. I know it looks like a little ribbon, but it's a cursive L divided by 2. That's weird. We'll get to that in a second. A cone is similar, big B, but you're going to add pi r cursive L, pi RL. And then, like I said, surface area of a sphere, totally off on its own, but it's not hard. They're pretty easy. 4 pi r squared. You take pi r squared, which is the area of the circle, and multiply by 4. 4 pi r squared. Done. So let's talk about what that cursive L is. There's some things on here you should already know. Big B means area of the base. P means perimeter. Little cursive L means the slant height. When you're finding the surface area of a figure that's slanted, I need the height of that actual slant, right? The height of the pyramid of like, think of the Egyptian pyramids of Giza, right? The height is if you were to start at the tippy top center and go straight down inside to the middle of the pyramid on the inside of it. But if I wanted to find the area of that triangular face on the outside, I wouldn't use that number in the middle. I would take the triangle on the outside and find that slanted height, right? That triangle's got this face like this. I need the height going straight down the side of the pyramid, not the inside height of the pyramid, the actual height of that slanted piece. So we call it the slant height. And then obviously R represents radius. So I got 3 examples to look at today. 1 pyramid, 1 cone, and 1 sphere. My pyramid is a hot garbage. Like, I don't know what I drew there, but just, pretend it looks like a pyramid, right? It totally does. The idea that I was attempting to go for there, keyword attempting, was that there is a square base on the bottom, and then here's the top of the pyramid, so this part connected up to the top, and then this part connected up to the top, and then this part connected up to the top, and then this part connected up to the top. That looks like way better. We're going to use that one. How's that sound? So what I found is that this side right here was 7 feet. This length right here is 7 feet on the base. And then I was trying to articulate that this length of the base is 8 feet. The part that's a little bit hard to see is this 10 right here represents this height going straight up, which I just discussed how that's not what I need, right? So that is the 10 feet going up. That's the actual height of the pyramid. But that's not what I need for area. And this is where we have to take a little aside, right? Think if I were to slice this pyramid. If you were to take a slice out of the center of the pyramid, this piece right here, that would be the center of the pyramid if you're looking straight on, right? I know that the base down here is 8 feet long. And I know that this height that comes straight down is 10 feet long. So if I wanted to find the volume of the pyramid, this would be really useful. But I don't want the volume. I need the area of the face on the side. So what I need to know is I need to know how long this piece right here is. How long this height right here is. So what I can do is I can create a little right triangle from this, right? If this 8 is the whole thing and I'm cutting it right in the middle, then I know the base of this right triangle is 4. I know the height of this right triangle is 10, and I can solve for h. So we're going to use some Pythagorean Theorem here. We're going to do a squared plus b squared equals c squared. So 10 squared plus 4 squared equals h squared. So I get 100 plus 16 equals h squared. and I get 116 equals h squared, which I square root and square root. And did I actually give you a decimal for it? Let me look real quick before I keep going. I think I did at the end. I waited until the end, so hold off with me. We know that h now is equal to the square root of 116. We'll get back to that in a minute. Okay, so that piece is critical for solving this problem. Now I can come back in here and I can actually figure out some things, right? In order to use the surface area formula here, the surface area formula here is big B plus the perimeter times the height divided by 2. So I need to figure out what the area of the base is. Big B. Well, the base here looks like it's a rectangle, right? It's a 7 by 8 rectangle. So I'm going to use the formula we're going to use the formula base times height of the square or the rectangle. Well, the base is, it doesn't matter, base or height can be 7 times 8. Remember, this height is not the same as this height over here. This is height of the actual pyramid, right? That's height of the pyramid. Height of the rectangle is talking about this 7 by this 8 right here. So 7 times 8 is going to give me 56, and now I've got big B. I need to know what P is. Remember, P is perimeter of the base. So I'm going to add together 7 plus 8 plus 8. Those are my 4 sides of that rectangular shape. So when I add 8, 16 plus 14, I'm going to get 30. And lastly, I needed h, which I determined was the square root of 116. Approximately, I wrote down that was 10.77. That said, I don't want you to do that until the end of the problem, because you don't want to round too early and make a mistake and have the wrong answer because you rounded too soon, right? That's super important. So let's plug this in then. Surface area is equal to big B, which we've determined is 56, plus the perimeter times the height. So 30 times the square root of 116 divided by 2. So we're going to take this and plug this in. 30 times 116, square root of 116 divided by 2. That gave me 56 plus 161.55. And then I went ahead and added that together, and when I did that, I got 217.55. And since we're talking about surface area, we'll do squared units, so feet squared. And that would be the surface area of that pyramid. Some people may be saying, like, okay, where did this, like, area of the base make sense, right? We need that for our surface area of the base. Where did this pH plus 2 come from? Well, if you think about it, when I draw the net of a pyramid, right? Think if I drew this instead like this. Instead of putting it along all the sides, we could just do this, right? If I folded those all up, they would wrap around and attach here and here and here. Well, the perimeter of the base is going to give me the base of these triangles. Then I'm multiplying it by the slant height, which is the height of these triangles. And because it's a triangle, we divide by 2. Base times height divided by 2. Base is the perimeter. Height is the slant height divided by 2 is because it's a triangle. So really, it's just the area of a triangle formula, and that's why we're doing perimeter times height divided by 2. I don't know why I wrote that. You all notice this? I put H up here. That should have been L, right? Slant height. And this should have been L as well. I don't know why I used H. I'm sorry if that was confusing. That should have been the L. All right, so just to show you real quick, here's the nicer version, Mr. Knox handwritten version that is way prettier because I write better in person than on this pad. I'm getting better, though. I will say my writing on this pad is definitely improving from day one when it was a total disaster. So there's example 1. Go ahead and pause it if you need it. I'm going to jump into example 2. So example 2 asked us to find the surface area of this cone. Okay, so surface area of a cone, in case you don't remember the formula off the top of your head, since we just learned it, surface area equals area of the base plus pi RL. I don't know why that one I remember it. Pi RL just sounds like a fancy thing, right? Pi RL. Pi RL. It's easy to remember. Pi RL. So big B, well, in this case, again, check if we have the slant height, which in this case we do, right? They didn't give us the actual height of the cone, which will be useful for volume next week. They gave us this height on the side, this slant height, which is good. That means I know what cursive L is already. So area of the base is going to be equal to the base area, which in this case the base is a circle, so we're going to use the area of a circle formula, pi r squared. I know that the radius here is 5 inches, so I'm going to put pi times 5 squared, which is ultimately going to give me 25 pi. So there's my big B. I already know what pi is. How about the r? Well, we just used that, right? The r is 5. I'm going to need that. And last is that slant height, which I said we already had here. This one's really nice and easy because they already gave us the slant height. I wanted to show you that you don't always have to use Pythagorean Theorem to find the slant height. Sometimes you do, sometimes you don't. It just depends. Did they give you the real height, or did they give you the slant height? If they gave you the slant height, you're great. If they gave you the real height, you have to find the slant height. That's going to be backwards next week, because next week for volume, you need the real height, not the slant height. So we can just plug that in now. 25 pi plus pi times the radius times the slant height, pi RL. And we'll work that out. 25 pi, 5 times 16 gives me 80, so I have 80 pi. And 25 pi plus 80 pi gives me 105 pi inches squared, since it's area, surface area. That's it. So again, just to put that over in the nicer, prettier version. Boom, there it is. Again, pause if you need that. I'm going on to my last example, example 3. Like I said, spheres don't really fit in here, but we're going to do it here because they're not hard. They're pretty straightforward and simple for their surface areas. Surface area of a sphere is 4 pi r squared. The only way I might make this hard is if I gave you a diameter instead, right? I may give you a diameter and ask you to find the radius, but in this case, I gave you a radius. I know the radius is equal to 8, so done. I just plug that into the formula. You have everything you need already. With one piece, you have everything you need. So 4 pi 8 squared. 8 squared is going to give me 64, so I have 4 times pi times 64. Let's multiply that 4 and that 64 together, and if I do that, I get 120. I get 256 pi. And I think I just left it in terms of pi because it didn't say whether or not to, so let's just do that. So feet squared, 256 pi feet squared. Look at that, super easy. Done, done, like that. Again, coming back over here to this nice version. And there it is not. There it is. And there's the nice version. So that's all you need. That's how you do your prisms and cones, or sorry, your pyramids and cones for your second IXL and your spheres for your third IXL. They may ask you to work backwards on those. They may give you the surface area and ask you to work backwards. So be mindful of that too. There might be some other ways they ask them, but as always, I'm here during my office hours to help you out. 11:30 to 12:30 Monday through Friday, and 2 to 3 Monday through Friday on Zoom. Make sure you check the Google Doc. All that info's on there so I can help you out. Bye, y'all. Have a great week. Miss you all so much.